Welcome back. We move things outside because Jesse Miller is going to be not exploding, but making a mess, right?
That's right, making a big mess. Yeah, and I had to have move the trucks and stuff away from here this morning because it's going to shoot a lot of sparks up, and I make sure I'm not directly under the lines and stuff because you never know about thermite. It's not exact.
So what's a thermite?
Okay, so thermite, what it is, it's basically rust, iron oxide, and aluminum powder. You put these together, and it produces a lot of energy. Okay, and it kind of does this little atomic musical chairs things where the oxygen goes from the iron, the rust, and goes and oxidizes the aluminum, and so then you get aluminum oxide, and you get pure iron. And this produces so much heat that you'll actually see on the bottom of this molten iron coming down the bottom.
Wow.
Now, they used to use this thermite reaction to weld railroad ties together.
Yeah.
Or not the rails, not the ties. And back in the days before they had, modern welding techniques and stuff like that. So in order to weld these things together, they would put some thermite on top of it, set it off, and the heat would just weld the two steel pieces together. It's pretty spectacular.
Okay.
So now, in order to get this to go, because if you just mix them together, obviously it's mixed together, but it's not going. It's in a clay pot here.
Sure.
So we have to add some heat to it in order to get it to going. And then once it gets going, it'll be fine. So this is glycerin. And I have, on top of the mixture, I have some potassium permanganate. Glycerin and potassium permanganate will ignite and give off a small flame, which will ignite the thermite. So this takes about 30 seconds. We'll go ahead and get it started here. You should never look down on top of this.
Why? In case it doesn't take
in case it goes off, and it goes right off in your face. So let's step this way. Okay, so it's a little cold out here, so it might take just a little bit longer, but we should see here pretty soon the glycerin start to react with the permanganate. I know it's a little boring right now. Come on. It's the one problem with doing things in the cold is it slows reactions down quite a bit. But once the glycerin goes with the permanganate, and here we go, we're getting smoky here.
So should we be looking at the top or the bottom of it?
Well, the whole thing. Here we go. There's the permanganate, and then there's the thermite. Now you can see the molten iron dripping down the bottom of it,
right.
And if you get a tight shot on the bowl down there, you can see that's actually molten iron. And so what we've done is we've transferred the oxygen from the rust to the aluminum. So now we have aluminum oxide and we have molten iron.
Okay, so what can we learn from this?
Well, I mean, it's just cool chemistry. It's oxidation reduction chemistry, and a lot of explosives that we have out there is redox reactions. It's just moving. One thing is reduced, and the other thing is oxidized, and it gives off a lot of energy. Batteries work the same way, where electrons are given from one thing to another, and then we harness that energy to produce electricity in the battery. So redox reactions are extremely important. This is just a fun one that we can go and show, but it also shows that you don't need necessarily to have pure oxygen in order to get the thing going. Now we do have oxygen in there, but we can also have redox reactions without oxygen. Just because it has oxygen in it doesn't mean it has oxygen. And in the future, I'll probably do one with what we call aluminum and iodine. Does the same thing, only there's no oxygen in it, and one's reduced and one's oxidized.
And then the difference?
And the difference, and it produces a lot of energy. So chemical energy, there's a lot of energy and chemical energy out there, and if we can just harness it, we can have different alternative fuel sources. I don't think we'll be using thermite in our cars anytime soon, but it is a fun reaction to go.
Okay, Jesse Miller, thanks for being with us, showing us these fun chemical reactions. And we're going to put it on our website if you want to learn all about it again, IllinoisHomepage.com.